Hello, in this video we are working through example 1 in section 8.1 for day 1. We are asked to find a formula for the general term an of the sequence 1, 4, 7, 10, assuming that the pattern of the first few terms continues. So in other words, we're going to be finding an explicit formula for the given sequence. So an explicit formula means that we need to find a formula or a function so that an, the nth term of the sequence, is equal to some function in terms of n. Now notice that this says assuming that the pattern of the first few terms continues. So that means that we need to find a pattern to find what our function is. So to find our function f. So let's write out our terms. A sub 1, our first, is 1. A sub 2 is 4. A sub 3 is 7. A sub 4 is 10, and it would continue from there. Well, notice that our second term is just equal to our first term, which is 1 plus 3. Excuse me for that. Let me turn down my volume real quick. Okay, so we have 1, which comes from our first term, plus 3. Our second one is equal to our previous value, or our third one, sorry, is equal to a previous one plus 3. So that would be 4 plus 3. But we know that 4 can be written as 1 plus 3. So this would be 1 plus 3 plus 3. Or we can think of this as 1 plus 2 times 3. The last one is 10, which is 3 more than our previous. So we could write that as 7 plus 3, but the 7 we know can be rewritten as 1 plus 2 times 3. So we have 1 plus 2 times 3 plus 3. Or now we have 3 3's being added, so we're going to have 1 plus 3 times 3. So let's see if this is enough to get a pattern now. We have 1 plus 3 times 3, 1 plus 2 times 3. Those two are pretty similar. The only difference is, whoops, wrong color. The only difference is this one number. So maybe we can write that in terms of a general n. The previous one is a 1 plus 3, but notice that we could write that as 1 plus 1 times 3. So now the only difference between this formula and what we have on the next two is that one number. So if we think of this pattern, then we've got a 3, a 2, a 1. This one should maybe have a 1 plus 0 times 3, and that does work out for our first number. So it looks like we have found a pattern here where almost all the things are the same between the different terms, except we just have this one number that is increasing each time. So maybe we can write that in terms of our index. So we have then that a sub n is going to be 1, because that's in each one of our terms, plus something, I'll come back to that, times 3. Now that something is always 1 less than the index for the term. We have a 3 over here when it's the fourth term, and a 2 for the third term, a 1 for the second, and a 0 for the first. So if we have an n here, then we need to have an n minus 1 right there. Or if we want to write it a little bit nicer, we would have a sub n is equal to 1 plus 3 times n minus 1. And there is our explicit formula. So that's the first part of this example. The second part says, using this formula, calculate what the 8th term of the sequence is. If we were going based on the pattern that we saw, where we just added 3 to the previous one, we could eventually get to the 8th term. But we'd have to calculate the 5th term, the 6th term, the 7th term, and then we get to the 8th term. In this case, it wouldn't be too hard. But you could imagine, what if we wanted to get the 50th term or the 100th term? That wouldn't be very nice if we just followed the pattern of adding 3 every time. But the explicit formula does work really nicely for that. But in this case, we want the 8th term. So for the 8th term, this would mean that n is equal to 8. And I'm sorry, I forgot to write something here with our explicit formula. We need to know a place to start, what n value we started at. When I was writing out these terms, I chose to start it at a sub 1, so that means n starts at 1. So here we need the explicit formula, and we need to say this is true for n equals 1, 2, and so on. Okay, for full credit, you do need to have where n starts. If you don't have a place to start for n, then you don't really know what the terms of your sequence are, okay? So anyways, back to what we were saying with the 8th term. That means that n is equal to 8. So a sub 8 is going to be 1 plus 3 times 7. I'm sorry, my brain just got distracted by something. That's going to be a 22 there. Okay. So our final answers then are going to be a sub 8, the 8th term, is 22, and a sub n is 1 plus 3 times n minus 1 for n equaling 1, 2, and so on and so forth.